So in earlier video, we have seen the heterojunction structure of LED in which there is a different layers of different semiconductor material having different mole concentration of the elements. Now LED are of two types. First one is the surface emitting LED, and here you can see the structure of this surface emitting LED, and these two layers are the confinement layer. This is showing the double heterojunction layer, and the middle one here, when here this one is the active region. So the middle one is the active region, and the two layers, and this active region is in between these two confined layer, and this whole structure is the double heterojunction layer, and this is the substrate, and the substrate is etched, and there is etching is done in this substrate area. This substrate area is also made up of the semiconductor material, and in this area the optical fiber cable is cemented, and the this is done in order to receive the light. This fiber receive the light from this active region. This is the fiber, and from this region, from this active region, this is the active region from where the light is emitted, and this is the optical fiber cable which receive the emitted photon. So this is cemented in this circular area, and this is the bonding material, and here we can see the silica oxide isolation layer. This is the heat sink in order to absorb the heat generated while the recombination of the elect- carrier, majority carrier or minority carrier. So basically here, what you have seen, that the plane of this light emitting region. So this is the plane of light emitted region, and the fiber is attached to this layer perpendicular. This is the perpendicular to the surface of this substrate. Fiber, optical fiber is placed perpendicular to this. This is optical fiber cable, and this is the surface of this heterojunction LED. This is placed perpendicular to this surface. So this is the surface emitting LED. And here we have used double heterojunction structure. This is active region. This is heat sink. This is all about this surface emitting LED. This is the main point that is kept in mind, that the orientation of this optical fiber. So basically this is all about the surface LED, surface emitting LED. Now this is the diagram of edge emitting LED. So in this, again the structure is same. These two are the double heterojunction layer. This is the main active region from where the photons are emitted. These two are the guiding layer. This is the active area. This is the isolation layer. This is the heat sink. But here the plane of optical fiber is different as compared to the surface LED. And the dimensions are the different here. The diameter of fiber is 50 to 100 micrometer for the edge emitter. Here the plane is parallel. So this is the edge emitting LED, and this is highly directional. And what are the different material which is used for the designing of this two surface LED or this edge emitting LED? So basically we are using third or fifth group compounds, and here gallium, aluminum, and arsenide. Here these three elements are used in different mole proportion. X and Y are showing the proportion of this particular element. And on the basis of changing the value of this x and y, the immediate photon wavelength can be controlled. So the spectral width can be vary from 70 to 180 meter, when the wavelength range from the 3000 to 600 nanometer. And this can be done by using this parameter, x parameter. We can change this x parameter from 0 to 0.57 and we can get the different emissions wavelength that can vary from 920 nanometer to 600 nanometer. What does it mean? If the value of x is increased from 0 to higher value, then the wavelength is also changing from 920 nanometer to 1600 nanometer. So it depends on the mole fraction, on what mole proportion or what mole concentration we are using the different material in order to design these LED. So it will govern the emission wavelength. Now in this graph, you can see the lattice parameter and diode emission wavelength, how the band gap energy, diode emission wavelength and lattice parameters are the connected. So, and this one is the spectral width of the different LED type. So we have seen that there are two type of LED, age limiting and surface emitting. So the dotted line graph is of surface emitting LED, and here we can see the spectral width is around 125 nanometer, and this y-axis is showing the relative output power. So this dotted line is showing the surface emitting LED and having a spectral width of 125 nanometer, whereas in and this is about the age emitting LED, that is 75 nanometer. So now next, till now we have discussed about the structure and their spectral width. Now next we have to calculate the quantum efficiency of the LED. So for this we will discuss the mainly we will discuss the bulk recombination rate, and from this bulk recombination rate we will calculate the quantum efficiency, and that can be of two type: external quantum efficiency and internal quantum efficiency. So in next lecture we will discuss about that. We will derive the formula for the efficiency of the LED.